I'm going to explain why the stars show that the Earth is a globe, or the sun for that matter. So here's the flat Earth. Alright, we'll start with that. The basic model, you've got the North Pole in the center, and the continents kind of go out from there. America, South America, Eurasia, Africa, Australia, and then the Antarctic kind of goes around it, right? Alright. So, circumnavigation on the flat Earth is a circle. Instead of going around the world, we go in a circle around the North Pole. So we would go something like this. If we were traveling west, we would go around the North Pole, come back to where we are. Alright, so a couple things. The sun also does this on the flat Earth. It goes in a circle instead of going around us, right? It takes 24 hours to do this. So 360 degrees for a circle is 15 degrees an hour. Alright, at the equator, so we've got 15 degrees is equal to 1 hour. The distance between these, for 1 hour, you could judge by solar noon. So when it's solar noon here, an hour later, 15 degrees later, it'll be solar noon here. On the equator, that's approximately 1,040 miles. You could also look at a star above your head, and while stars move just slightly faster than the sun, for this purpose we'll say they move 24 hours also. So you have a star directly above your head here, 15 degrees later, 1,040 miles to your west, that same star will be directly overhead there. So we can use this to navigate in the northern hemisphere. You've got Polaris, which you could look at its angle, and if it's right above you, then you're obviously at the North Pole. If it's right on the horizon, then you're at the equator. And the stars go around it counterclockwise. Now, as I said, just like with the sun being overhead or solar noon, you could use these stars to go around. So the star directly above Polaris, the star next to it would represent right there if it was right above your head. The star next to that would be right there if it was right above your head, and so on. And the circles get bigger and bigger and bigger until they get to the equator. Once you get to the equator, whether you're looking at the stars or the sun, this 15 degrees that represents 1,040 miles never gets bigger. It starts getting smaller. So you could measure this with the sun. You could come down here and you could look at solar noon, an hour apart, east-west, and see what that distance is. Smaller than 1040 means these circles get smaller. There's only 360 degrees in a circle, 24 hours in a day. 1 hour is always 15 degrees. 4 minutes, 1 degree. So let's say we don't want to do all that with the sun. We can also look at the stars. And the stars work the same way in the southern hemisphere for navigation. That is to say, if you have a star above your head, it'll move 15 degrees an hour approximately. And that 15 degrees will represent a distance on Earth. Because it takes about 24 hours for it to go around. A little under, but close enough for this purpose. So when you look at the southern sky and you see the stars getting smaller and smaller and smaller on those arcs. That corresponds to the distances here, getting smaller and smaller and smaller. You cannot have on a flat circle, starting in the middle, you cannot have circles get bigger, 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 and then get smaller again. Any circle outside of this would have to be bigger. The only way they can get smaller is if the Earth's a globe. So if you're looking at the side of the Earth, you would see these circles going bigger, bigger. Get to the equator, then they would go smaller, 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 smaller. That's why the stars demonstrate that the Earth is a globe. Perception doesn't change this. There's 24 hours in a day. There's 360 degrees in a circle. 15 degrees of movement is 1 hour. The stars don't move at different speeds. Their angular speed is not different. That is to say, they all move 15 degrees at the same rate. And they'll all move 360 degrees in roughly a day. Perception, refraction, mirrors, reflections, perspective, none of that changes this. The stars do correspond to locations. And because they do correspond to location, these arcs correspond to distances. And because these arcs correspond to distances and locations, it's demonstrable that the circumnavigation of the Earth is not an ever-increasing circle. It is longest at the equator. East-west distances are longest at the equator. And then shorter as you go north, but they're also shorter as you go south. And that just does not work on a flat Earth. And you can test it for yourself.